When we talk about creating scatter plots or calculating the correlation coefficient as ways of understanding the strength of association between two variables, it is critical that we understand and always keep in mind that association or correlation does not ever imply causation. If we think back to the couple of examples we've already looked at, the first one was roller coasters and tsunami aid. It is very unlikely, probably even unreasonable, that having more roller coasters in your country causes you, as a country, to contribute more money to tsunami aid. It is very unlikely that the number of UFO sightings causes the number of ghost sightings. What we're looking at is just cases where those two variables change together. What it can be, though, is an important first step in research. If we were to consider two variables like gun ownership and violent crime rates, there are a few different possibilities that we could see if we collected that data and calculated the correlation, looked at the strength of that association. We could see a positive association, which would mean that both variables change in the same direction. So that would tell us that as gun ownership increases, violent crime rate also increases. That could be an important thing. That could be a cause and effect relationship. But more research would have to be done to understand that. Looking at the correlation would just tell us that the two things change together. There could also be a negative association. Again, negative in this case doesn't mean bad, just means that the variables change in the opposite direction. That would imply that as gun ownership increases, the violent crime rate decreases. Decreasing violent crime would actually be a good thing. So we'd just be looking at if there's an association there. The other possibility is that there's just no association. So no clear pattern or connection between gun ownership and violent crime. If we looked at those two variables, looked at real-world data on those two variables, whichever of those three outcomes we get would then help us determine if that is something that's worth investigating further to see if there is a cause and effect relationship or what else is causing those variables to change with that same pattern. So, the lack of an association can also be informative, because if we see that no association exists, then it might not be worth investigating something like gun ownership and violent crime rate. If those two variables can't be, if we can't determine that there's any connection between those, then further research wouldn't likely yield anything very informative for us. But to continue on this trend, because it's a common misconception with correlations and associations, what would it mean if association did imply causation? Well, in example 5, that would mean that US spending on science, space, and technology would cause more people to commit suicide by hanging, strangling, or suffocating themselves. I think it's pretty clear that there's no real cause and effect relationship between those two variables, but if we plot those, this is real-world data, we get a value for R of 0.9921. In example 6, it would tell us that people drowning in swimming pools each year would cause Nicolas Cage to appear in more films each year. This correlation isn't quite as strong, but 0.6660 is closer to 1 than it is to 0. In example 7, if associations did imply causation, if correlations did imply causation, then people getting divorced in Maine would cause people to buy more margarine. In this case, an incredibly strong association, 0.9926. And on our last example, People dying by being strangled by their bed sheets would cause skiing facilities to make more money. Again, a very, very strong association between those variables that we can probably just intuitively determine has no cause and effect relationship. But something like gun ownership and violent crime, studying and test scores, things that we think might have a cause and effect relationship, determining that an association exists can give us a starting point for more research, or if we conclude that no association exists, helps us refocus research into another area. In all the cases that we talked about above, these kind of ludicrous examples of strong associations but no cause and effect relationship, what's probably going on is that there's something referred to as a lurking variable, or maybe several lurking variables, that are causing those different variables to change in that same direction. So, the number of people dying by being strangled by their bed sheets isn't causing ski facilities to make more money, but there are some other variables that weren't accounted in our study and our data collection that are causing both of those variables to trend in an increasing pattern. So, as you encounter statistical information in the real world, just keep in mind this very important idea. Association does not imply causation. When scientists or researchers find a link between two variables, does not mean a cause and effect relationship, just that they happen to change in the same direction, and more investigation is needed to determine if that's really cause and effect.